Hey everyone, Geek37 back with part 13 in my study of the heptagonal triangle. And what we're going to do today is we are going to establish some more trig ratios that are involved with this triangle. As a review, you know that the heptagonal triangle is the key scalene triangle in the regular heptagon, and it is set up in such a way that the angles double from least to greatest, starting with pi over 7, and then 2 pi over 7, and then 4 pi over 7. And then the sides that are opposite those angles, for example, pi over 7 is opposite side A, 2 pi over 7 is opposite side B, and C is opposite 4 pi over 7. Now, as you can see on the left side of the screen, I showed these in prior videos in this series where those sine ratios and those cosine ratios came from. What we're going to do is we are going to establish the rest of the identities: tangent, cotangent, cosecant, and secant. What I am going to start off with is, let's start off just doing the cosecants of pi over 7. If you remember your basic trig, you know that that is a reciprocal identity of sine. So what I'm going to do is I'm going to take a over 2r and just put that as 2r over a. That is cosecant of pi over 7. Cosecant of 2 pi over 7 is going to be 2r over b, and cosecant of 4 pi over 7 will equal 2r over c, just like that. So those are the three cosecant ratios related to the heptagonal triangle. Now what I'm going to do next are going to be the secant ratios of the heptagonal triangle, which are just the reciprocal relations of the cosine ratios. So the secant of pi over 7 is going to be 2b over a. The secant of 2 pi over 7 is going to be 2b over c. And the secant of 4 pi over 7 is going to be negative 2c over a, just like so there. A couple other ones that I have not established is the secant of 3 pi over 7, and that is going to be positive 2c over a. I'm not going to go in depth on why that is. Just remember, because of how the cosine of pi minus an angle will equal the negative cosine of the original angle, the same is true for secant. So that's why the secant here is positive. And the cosecant of 3 pi over 7, that is going to also be 2r over a. Again, because of the sine of 4 pi over 7 equaling the sine of pi minus 4 pi over 7, which equals the sine of 3 pi over 7. The reciprocal relationship will work that way as well. So that is why the cosecant of 3 pi over 7 is equal to 2r over a, just like the cosecant of 4 pi over 7. So that establishes the ratios. That establishes the ratios for cosecant and secant. Give me a couple of seconds while I do some clearing of the screen. Now let's go through and establish the tangent ratio to start with of pi over 7. Now here's what happens. The tangent is going to be the sine of pi over 7 over the cosine of pi over 7. So we are creating a reciprocal with the cosine. So what happens is we get a over 2r times the reciprocal of the cosine ratio, which will be 2a over b. The 2's will cancel, so we'll get a squared over rb. That is the tangent of pi over 7. Now the tangent of 2 pi over 7 will be that will also be the sine of 2 pi over 7 over the cosine of 2 pi over 7. So we'll get b over 2r times the reciprocal of the cosine ratio, which is 2b over c. Cancel the 2's. We'll get b squared over cr, just like so there. And the tangent of 4 pi over 7 is going to be the sine of 4 pi over 7 over the cosine of 4 pi over 7. And what will happen is we'll get c over 2r times the reciprocal, so it'll be 2c over negative a. 2's will cancel, and we will get cosecant squared negative a over r, just like so there. So those are our 3 tangent ratios right there. And let me clear the screen so we can have space for the next part. All right, everyone, as you can see, I have the tangent ratios boxed off there, and off to the side, I have the tangent of 3 pi over 7. That is positive because of the way the sine rule works, since it's sine, or because of the way the cosine works. Remember, the sine is negative, the sine is positive from 0 to 180, but the cosine becomes negative between 90 and 180. So the thing is, the tangent of 3 pi over 7 is an acute angle, so that is why we have the positive version over there. And again, the reason why I do bring the 3 pi over 7 into it is because that is a key angle that we have used in the regular heptagon, and it is an analog of 4 pi over 7. So it does play a role in the heptagonal triangle as well, but it's kind of hidden in the background. So let's finish off this portion of the video. What we're going to do now is we are going to do, sorry, I'm trying to get this just right here. Okay. So what happens is, apologize for my, so what happens is we reciprocate the tangent ratios to get cotangents. So I'll get RB over A squared. I will get CR over B squared. And then I will get negative AR over C squared, just like so there. And those are the cotangent ratios for the heptagonal triangle. And of course, because of the way cotangent and tangent work, and again, because of the way sine and cosine work, 3 pi over 7 is an acute angle, so therefore it is going to be a positive version, unlike the 4 pi over 7. And that concludes the main portion of the video with the trig ratios established for the 6 trig ratios established for the entirety of the heptagonal triangle. Now what I'm going to do is I am going to do a couple of trig identities related to this that uses what we just have here on screen. Give me a second while I clear everything out. Now, this one is an interesting discovery that I made kind of after the fact, playing around with these ratios. So what I'm going to do is I'm going to take cosecant of 4 pi over 7 plus the cosecant of 2 pi over 7, and I'm going to write down their associated variable ratios. So 2r over c plus 2r over b. Now, you'll see something kind of interesting here. Notice that the numerators have the same variable components there. What you can do is, because of that, you can actually factor it out, and you'll get 1 over c on the inside plus 1 over b. And there's something interesting about this. I established earlier in the series that 1 over c plus 1 over b equals 1 over a. This again is called the optic equation. It's one of the more well-known relations found in the heptagon, regular heptagon, and the heptagonal triangle. So what happens is we will rewrite the next part as 2r times 1 over a. Well, 2r times 1 over a is just 2r over a. And what is that? Well, that is the cosecant of pi over 7. So the cosecant of 4 pi over 7 plus the cosecant of 2 pi over 7 equals the cosecant of pi over 7. And the thing is, remember, the cosecant of 4 pi over 7 is equal to the cosecant of 3 pi over 7 because it is the reciprocal of the original sine ratios. So therefore, cosecant of 3 pi over 7 plus the cosecant of 2 pi over 7 equals the cosecant of pi over 7. I find that to be pretty cool because, as you can see, in the relation I derived above, we see 4, 2, and 1, 4 pi, 2 pi, 1 pi going down in that geometric progression. But now if you look below, you got 3 pi, 2 pi, 1 pi, and that's going down in an arithmetic progression. And I find that to be quite interesting. I have one more identity that I want to derive from the ratios that we had before. So now the identity that I'm going to derive is the secant of 3 pi over 7 plus the secant of pi over 7 minus the secant of 2 pi over 7. And the reason I have to use 3 pi over 7 is because it's positive and it will not work if I do secant of 4 pi over 7. So that's why I'm doing it. So what we're going to do is we'll write down the variable ratios that we derived earlier, and that will be 2c over a plus 2a over b minus 2b over c. Now, as you can see, yeah, we've got different variables in the numerator and the denominator, but you'll notice that there are 2's shared in the numerator, so we can actually factor that out, and we are left with fractions on the inside, c over a plus a over b minus b over c, just like that. Now, you have seen this before, and I'm not going to do the full derivation. This is in one of the prior videos in the series, but if you remember that c over a plus a over b minus b over c, that actually equaled a specific value. That equaled the exact value of 2. So what happens is we replace the entire parentheses with 2. So 2 times 2 is 4. So therefore the secant of 3 pi over 7 plus the secant of pi over 7 minus the secant of 2 pi over 7 equals 4. And that concludes the video right there. And this video got to be somewhat long. I try to limit my time to about 10 minutes, but sometimes that just doesn't work that way, which is one of the reasons why I didn't do the algebra on that parenthesis portion of the problem here. So again, I try to factor in time and space constraints, as I call them. I can make this video as long as I want, but I don't want to make it boring either. So in summary, again, I wanted to show the rest of the trig ratios that come from the heptagonal triangle. I wanted to show a couple of identities that that naturally arise from it, and I felt like I did that today. I hope you enjoyed this video. I enjoyed making it. This is Geek37 signing off.